I welcome you all for the wireless communication lecture module. In this lecture, we are going to discuss about a MSK. MSK is nothing but a minimum shift keying. To overcome the non-linear effects in the FSK as well as the QPSK, we have gone for the concept of a MSK. So in a normal FSK, here the zeros and ones are represented with the different frequencies. Zero is represented one frequency and the one is represented with the another frequency. Whenever we have a transition from 0 to 1 or 1 to 0, okay, along with the frequency transition, some amount the phase of the signal will also changes. The phase transition will also occurs in case of a FSK. So this phase change at the transition point 0 to 1 or 1 to 0, that creates a non-linear effect in the system. Okay, so to overcome the drawback, we have gone for this MSK. So MSK is nothing but it is a special type of continuous phase FSK. Okay, so the there are two types of FSKs there. One is continuous phase FSK and the second one is a differential phase FSK. So in the differential phase FSK, whenever the transition from 0 to 1 or 1 to 0, again there will be some phase shift, that is called as a differential phase shift FSK. But in case of continuous phase FSK, whenever there is a transition from 0 to 1 or 1 to 0, the signal, the F1 to F2 will go continuously. There will be only frequency change. There is a no change of phase at the particular point. That is called as a continuous phase FSK. So MSK is a continuous phase FSK. Similarly, the second advantage is MSK is a special type of FSK. So here the frequency deviation is kept at a 1 by 4 of bit rate. That is, the modulation index is kept at a 0.5 to maintain the orthogonality of the signal. So 2f or del f, that is the frequency deviation, fh minus fl, no, which is equal to rb divided by 2. Okay, so here we have a 2, so no, the bitrate rb divided by 4. So here to maintain the orthogonality, the modulation index is kept at a 0.5. So these two are advantages of MSK as we compared with the FSK. And then we are going to discuss about the generation of a MSK or modulation, MSK modulation. So here the X of t, the input X of t will have a four components. Is a sine component, okay, off sine wave component, cosine component, and a off cosine wave component. So the input X of t will have a, all the four components. So look at the black diagram. Here we have a two inputs, cos 2 pi fct and cos pi by 2 t and divided by capital T. So these two are inputs. Okay, so these two inputs only have the cos components. Okay, as when we have a in phase and quadrature phase component, now we need sine component as well as cos component. But here with the help of two cos components, by multiplying these two cos components, we are getting a cos component as well as sine component at the output. Okay, so the two cos components are multiplied, and then the multiplied signal is divided into in phase component as well as a quadrature phase component. Then these in phase as well as quadrature phase components are given to the band pass filter. Here the band pass filter is tuned with the frequency f1 for the in phase component at the top, and then it has been tuned to f2 for the quadrature phase component at the bottom. So we have a in phase and a quadrature phase component. Okay, so at the output of the band pass filter, we are extracting pi 1 of t as well as pi 2 of t. Okay, so with the help of again mi of t and then mq of t in phase component as well as a quadrature phase component, we are applying mi of t and mq of t with the output signal. Okay, and finally we are getting a x of t in phase as well as quadrature phase. So both the in phase and quadrature phase component are added, sum up together, and finally we are getting the MSK signal. Yes, MSK of T. which is at the transmitter side. This is how we are generating a MSK signal. So instead of using a cosine term, we are using so instead of using sine term, we are using a two cos terms. Okay, with the help of these two cos term itself, by multiplying this, we are getting a sine term. Okay, so that we are dividing the signal into in phase component as quadrature phase component. Finally, after tuning up the frequency, after extracting the in phase and quadrature phase component, finally these signals are added up together and transmitted. This is at the modulation end or transmitter end. Then we have a MSK reception. So the received SMSK of T is first divided into in phase component and a quadrature phase component by multiplying these with the x of t and y of t. These are called as a basis function, which is also referred as pi 1 of t and pi 2 of t, which is used in the transmitter side. So after applying this basis function, no, we are extracting cos component in the in phase at the top and then only sine component at the bottom, that is called as a quadrature phase component. So we are extracting cos component as well as a sine component, which are normally denoted as in phase as well as a quadrature phase. So after this, we are applying this signal to the integrator, okay, individually at the different time interval. Cos signal will be given to the integrator with a different time interval, and then again the sine signal will be given to the integrator with a different time intervals. So after applying this, with the help of a threshold device and decision device, we are getting the in phase component separately and then quadrature phase component separately, mi of t and mq of t. Finally, these mi of t and mq of t are combined together to get the original transmitted information. This is called a MSK reception. So here at the transmitter side, we are generating in phase and quadrature phase component. We are summing up together and transmitted. At the receiver, once the signal is received, the signal is again divided into in phase component as well as quadrature phase component. We are extracting cosine component and sine component individually. And then finally, we are adding up these in phase and quadrature phase component to extract the original information. This is at the MSK reception. And then finally, we are looking at the what are the advantages of a MSK. So as I already mentioned, MSK used to remove the non-linear effect because it is a continuous phase FSK. And then second one is the modulation index is kept at a 0.5 to maintain the orthogonality that will reduce the interference. Along with these two advantages, here if you look at the power spectral density function of MSK, okay, which is denoted as the straight line, okay, and the dotted line is denoted as QPSK and OQPSK. So when you will refer these two QPSK as well as MSK signal, that the MSK has a wider main lobe when compared to the QPSK as well as OQPSK. So because of this wider main lobe, we can able to transmit more information within that major lobe. We have a wider bandwidth in case of a major lobe. This is the one advantage of MSK. And then the side lobes are decaying. Second one, if you look at the side lobes, as the side lobes are decaying faster level in MSK as we compare to the QPSK. So we can accommodate more information than QPSK, the first advantage, and the side lobes are decaying much faster as we compare to the QPSK. These two are advantages of MSK as we compare to the QPSK. This is about a minimum shift keying. So minimum shift keying is to overcome the non-linear effects of a FSK. So for this, we are using a continuous phase concept to remove the non-linearity, and then we are maintaining modulation index 0.5 to maintain the orthogonality. And then with the help of a in phase and quadrature phase component, we are combining them and transmitted. Similarly, we are extracting in phase and quadrature phase separately and then added together to get the original information. This is MSK modulation and a restriction. Finally, the advantage is that we have a wider bandwidth, so we can accommodate more number of information. And the second one is that the side lobe levels are decaying much faster than the QPSK. That is also one advantage of MSK.